Hello everyone. Of mass. How do we find that out? By using any of these expressions. Hello everyone. Good evening guys. I am good. Thank you. Thank you for asking. All of you. Happy Raksha Bandhan sir. कल हो गया. Sir, you showed the answer for quiz. अच्छा. कोई quiz भी है? अच्छा. You did not show my message in live chat of YouTube. माफ कर दो यार, गलती हो गई. Hello. Sir, specs changed. हाँ ऐसे ही बस रखें, दो तीन बदलता रहता हूँ. सर आपने कितनी राखी बांधी? लड़कियां बांधती राखियां, लड़के नहीं बांधते. Sir tired. अरे I'm always tired यार. Sir, I am facing issues in what? In friction questions. Then watch the replays, go for a micro course, ask your doubts in the doubt panel, ask your doubts in the doubt section. Doubt app भी है. आपको कितने लोगों ने राखी बांधी? That's a secret question. That's a secret answer. I'm good, Samarita. Thank you. I'm good. Sir, voice is low. अच्छा, तुम्हारा कंप्यूटर या जो भी मोबाइल फोन है उसका वॉल्यूम बढ़ा के देखा तुमने? Did you try to increase the volume of your own device? Voice is good. Okay, that's good. Thank you. Thank you for asking. Thank you for telling the feedback. Guys, quickly say hi to your class teachers. Four awesome, fantastic four class teachers we have: Rishabh sir, Shubham sir, Gautam sir, and Amal sir. हैं? Will we be having same batch in 12th? अरे मेरे प्यारे कैप्टन अर्शद, पहले 11th तो पास कर ले मेरे भाई. 11th तो पढ़ ले पहले. अभी से फ्यूचर के बारे में बातें करना चालू. Sir, you got a Raki from your sister. So me and my brother are the only siblings. तो हमारी हमारी जो वॉलेट के अंदर पैसे हैं वो हमेशा हर साल बच जाते हैं. तो that way I'm lucky. So the amount of time that I'm studying, forget JEE, I won't clear 11th. क्या बात है? Sir, take a trip to Paris. क्यों भाई? ओके ओके ओके, चलो भाई, बहुत हो गया, बाद में करेंगे बातें, ठीक है. स्टार्ट करें एवरीवन. This is session number 1 of momentum and collision, but it is actually a natural extension of center of mass. Whatever we have studied in the previous session, that was center of mass, उसी को आज आगे बढ़ाएंगे हम लोग, ठीक है. अरे यार सिद्धार्थ बी मैं ब्लॉक कर दूंगा. सिद्धार्थ बी फॉर ब्लॉक हो जाओगे तुम, ठीक है. सर यू आर राइट हैंडेड. मतलब कुछ भी कुछ भी. चलो गाइस, आर यू रेडी? राइट +1 इफ यू आर रेडी. +1 इन द चैट बॉक्स. जितनी भी तुम्हारी इधर उधर की बातें हैं, सेव इट फॉर द एंड ऑफ द क्लास. ओके, चलो भाई, दैट्स ग्रेट. Okay guys, so switching off the chat so that we quickly take a recap and start session for today. Okay, yes, so chat is switched off now. Let's go and proceed with the session. Last time we spoke about the concept of center of mass. We understood that center of mass of an object is an imaginary point. It is not a real point, it's an imaginary point where we assume that entire mass of an object is supposed to be concentrated. Okay, and that point can be where the body's mass is present. It can be inside the body. Like if I speak about this bottle, the center of mass is inside the bottle definitely, right? Or the point location will be inside the bottle. But when we spoke about a ring, for a ring, the center of mass comes out to be at the center of the ring, where actually there is no mass present, there is no matter present. So it is not necessary that the center of mass will lie only where the mass exists. Center of mass location can be outside the body also. Also remember, center of mass is a point where entire mass of the body of the system is assumed to be put up. It means what? If there are 5 masses whose center of mass you are trying to find out, then at center of mass m1 plus m2 plus m3 plus m4 plus m5 total mass is supposed to be placed. Okay, and what we try to find out is the location of center of mass. How do we find that out? By using any of these expressions depending upon the requirement. Okay, m1 r1 plus m2 r2 plus m3 r3 up till as many particles which are there divided by the total mass. X coordinate, y coordinate, z coordinate. We can say that the overall location of center of mass, the position vector, is x coordinate of center of mass I cap, y coordinate of center of mass j cap, and z coordinate of center of mass k cap. This is how you basically try to find out the location of center of mass. Very importantly, we found the expression of center of mass for a few objects, and I told you to remember some of them. For semicircular ring and for semicircular disk, we found the expression. For semicircular ring, it came out to be on on the symmetry line, that is 2r by pi the location from the center of the ring, and from the center of the disk it came out to be 4r by 3 pi. For a hollow sphere, it came out to be at r by 4. For a solid hemisphere, it came out to be at 3r by 8. All of these are half objects, first 4. Then hollow cone, the center of mass is at a height of h by 3 from the base. Remember, from the base, not from the vertex, not from the tip of the cone. It is from the base of the cone, h by 3. Okay, so from the top it is 2h by 3. And similarly for solid cone, from the base it is h by 4, the location of center of mass. Okay, these are basically locations of location of center of mass for extended object. Okay, people, fine. Now we did solve a lot of questions last time, and there is a particular type of question that we could not solve previously. The question was there in the session PDF, whatever PDF that you will see for the previous class. This question was there. Now, everyone, I hope you people remember, before I even start this question, I told you guys that if we speak about a situation where, say, I draw an imaginary line on which the particle, or say 2 particles are placed. Okay, so I have 2 particles. Say this is m1 and this is m2, and their center of mass is somewhere here. If I assume this location of center of mass, which is m1 plus m2, okay, this is the location of center of mass. I assume that this location is basically origin. Okay, that means this is my center of mass. So I say that, okay, this mass is at a distance x2 and this mass is at a distance x1 from the center of mass or from the origin itself. So we came to a conclusion that now the x coordinate of center of mass is 0. So all the masses are placed on the x coordinate only, or x axis only. So I will say that it is m1 minus x1. Why minus x1? Because this side is negative x axis, this side is positive x axis. So m1 minus x1, m2 plus x2 divided by m1 plus m2. So this m1 plus m2 goes multiplies with this, and final expression came out to be m1 x1 equal to m2 x2. This is when we write, okay, this is when we write mass moment. This is called mass moments. When we write product of mass with the location of the mass. So product, when we write mass moments about center of mass, which means center of mass itself is at origin. That's when we got the expression, which is very important. This expression is very important for us. Okay, why we have done a recap of this? Because now what we are going to see, my method of solving this question depends upon the previous slide. m1 x1 equal to m2 x2. What the question tells you here, guys, it says that you had a square plate. You had a square plate. Okay, and from that square plate, whose side length is given to you as a. Pay attention, it's a very good question. And usually these kind of questions are expected in JEE examination. So if you have this square plate of side length a, from this you have removed a semicircular disk portion whose radius is obviously a by 2. You can see that the radius of this part is a by 2. Okay, so question is asking us that now the shaded portion that you see, the black portion that you see, this is the only part where mass remains. Okay, symmetrically the semicircular disk has been removed. So question is asking you to find out the center of mass of the remaining object. Okay, guys. So the point is, everyone, if we talk about the entire square plate, when the entire square plate was there, when nothing was removed, listen to me carefully. बहुत ध्यान से सुनना अभी. When the entire square plate was there, this is where the total capital M mass was present. Right, everyone? This is where the total mass capital M was present. Correct? This is where the total mass M was there. Okay. We also know that for the disk, the center of mass would be somewhere here. Okay, for the disk which has been removed, say that portion which has been removed is of mass m1. बहुत ध्यान से सुनना. The disk portion which has been removed, the location of the center of mass for that removed portion is at location m1. Okay, if I take you here, this location was 4r by pi. So we are now talking about the remaining gap. This gap is what we are talking about in this question, right, guys? So let's call this location to be x1. Okay, how do I find out x1? X1 is basically from the radius you are going to subtract 4r by 3 pi, because this used to be 4r by 3 pi. We did the derivation of this thing, 4r by 3 pi. So r minus 4r by 3 pi, and that basically comes out to be 3 pi minus 4 by 3 pi into r. And what is r, everyone? That is a by 2. So x1 comes out to be 3 pi minus 4, and r ki jagah pe a by 2 when I put, this is what I get. Okay, r is equal to a by 2. So we get it as 3 pi minus 4 upon 6 pi, or r becomes a by 2, so 2 multiplies with 3 pi. So we have got the location of x1, which is basically the portion, semicircular disk, which has been removed, the location of its center of mass. Okay, guys. Also, when I remove this semicircular disk, you know that due to symmetry, now the remaining mass, which is m2, okay, the remaining mass, which is m2, will be lying somewhere here. Okay, and we want to find out the location of the center of mass of this portion only. That means this is x2, which we are actually interested in finding. Okay, everyone, what was there earlier? The entire disk was there, sorry, entire square plate was there. Now we have removed the semicircular disk. So on the x-axis, due to symmetry, the center of mass has shifted by a distance x2. Definitely, that x2 is the location of the center of mass of the remaining portion. We are interested in finding that. Now, people, listen to me very carefully. If I bring this diagram in the form of point masses, listen to me very carefully. What I'm doing now. Okay, so on this imaginary line, just pay attention to this part, everyone. Okay, this is your origin line or y-axis. You can say what I'm drawing here, and everybody, this is the location of m2. This is the location of m1. This is x1. This is x2. So guys, my question to all of you, if I put back the m1 portion which has been removed, m1 is the removed portion, the semicircular disk portion. If I put it back so that I again get the entire square plate, okay, I'm thinking just reverse. Question says we have removed it. I say if we put it back, can I say that the entire center of mass of the square plate will come at the center only? This is where the total mass m will come, right? Everyone, do you agree with the thought in the chat box? Will come at the origin, right, everybody? Right? So can I say that if that happens, can we say that m1 x1 should be equal to m2 x2 about center of mass, which I explained it to you guys in the previous slide here, right? So अब ये logic लगाना है. If I get the value of m1 and m2, my question is solved. I want to find out x2, which is going to be m1 x1 upon m2. So if I get the value of m1 and m2, my answer is done. x1 का value we already have found. Okay, everyone, good enough. So pay attention, everybody. Yeah. So guys, let me try to find out the value of m1 and m2. Then we put the value here. So here I say that the portion that we have removed have mass m1, and the portion which is remaining has mass m2. How do we solve such questions? Is by assuming that the object is uniformly dense. And for 2D objects, we define surface mass density. What do we define? We define surface mass density, which is equal to mass upon area. And we assume that this is uniform, means this is constant. Say that value is represented by sigma. Okay, guys. So we say that for m1, the semicircular portion that you have removed, the mass of that portion is m1, and the area of that portion is written as pi r square by 2. Okay, and how much is the value of radius? It is a by 2. Okay, so how will I write the area? I will say it is pi r square by 2. Why pi r square by 2? Because it is half the circular disk. It is semicircular disk. So whatever is the area of a circular disk, I will be writing the area of half the value. This value should be equal to sigma. That's what we are saying. Okay, guys. So because this is r, which is equal to a by 2, so this is 2m1, 2 goes in the numerator, divided by pi a square by 4 is equal to sigma. That means from here, everyone, from here we get the value of m1 as, so let me simplify this further. This looks like 4 also goes in numerator. I have 8m1 upon pi a square equal to sigma. So m1 comes out to be pi a square sigma by 8. You guys get it? 8 comes in the denominator, and pi a square goes in the on the right hand side. Okay, everyone. Also, if we speak about the total disk or total square plate, the entire mass is capital M. Side length is a, so area becomes a square. So we can say that capital M is equal to sigma a square. So what will be the value of M2? Can you people tell me in the chat box? How will I find the value of M2? Because the shape is not a regular shape. I do not know the area of that portion, shaded portion. How do I find that? Can I say from the entire square plate, if I subtract the mass M1, I will get the value? Perfect. Very good, guys. Thank you. So I will say it is equal to sigma a square minus pi a square by 8 into sigma. Okay. So things which I can take common, I will do that, and I will try to utilize this space properly. So the problem becomes easy for us. Okay. This, when I write it directly taking sigma common, I will have a square minus pi a square by 8. That means 8 minus pi by 8 into sigma a square. Okay, guys, sigma a square. A square also comes out. Good enough, everybody? So what do I have here? I have M1, which is equal to pi a square sigma by 8. Okay, pi a square sigma by 8. And M2 comes out to be the value is 8 minus pi by 8 into sigma a square. Okay, guys, this is what we have. So look at this, guys. If we write sigma a square by 8, as small m, I'm writing sigma a square by 8 as small m. So from here, can I say that it is 8 minus pi into m? Do you guys agree on this? If I write sigma a square sigma by 8 as m, then sigma a square by 8 is m, remaining portion is 8 minus pi. That's what we got, 8 minus pi by 8. And now finally, we want to be here. We want to find out the value of x2. So m1 x1 upon m2. Good enough? So ek kaam karte hain. Let me put x1 here. Okay, dhyan dete jana. Do not deviate from this. Be with me. You will understand this. It is lengthy, no doubt, but it is a very important question. Okay, so we have to use this part now. We want to find out this value. So we want to find out x2, which is found by this. So m1 is pi m, m2 is 8 minus pi into m, and we have 3 pi minus 4 by 6 pi into a. Okay, so what do you see? M gets cancelled. Things which are getting cancelled will cancel them. I also get cancelled. What we are left with finally is x2. That comes out to be 3 pi minus 4 divided by 6 into 8 minus pi into a. That's the answer that we got. Have a look, everyone. Definitely not a very simple, straightforward question, but it is one of the very important methods to understand. I will just repeat what we have done. This thought process is very important. Question will always say that you have removed one portion from a given shape. Okay, so many people solve this question by the concept of negative mass also. Okay, negative mass mean the same formula that you learned here, m1 x1 plus m2 x2 upon m1 plus m2. People say that okay, you have removed the mass, so same question is done as m1 x1 minus m2 x2 upon m1 minus m2 also. But that method I personally do not vouch for. Maybe I'm not personally comfortable for. That's why I do not even speak about that method. I rather try to keep things more logical. So that's why I prefer the method where I have removed one portion. Why not I put it back? So if I put it back, the center of mass of the object will come at the geometric center. As simple as that. Okay, so whatever portion has been removed, I just need to find out the mass of that portion. I need to find out the location of center of mass of that portion. Okay, so we found the mass value m1, we found the mass value m2, we found the location x1, because we eventually want this expression m1 x1 equal to m2 x2. So we want to find out m1, we want to find out m2, we want to find out x1. x2 will be found easily. So that's what we do. In such questions, usually you will always require this approach, the surface mass density, unless the question says, in fact, in such questions, the question will always say that the object is a uniformly dense object, so that you can always talk about the surface mass density. Okay, guys? Good enough? If you understood this, just write +1 in the chat box, everyone. It is all mathematics after you understand the approach. Okay? Okay? Good. Okay. So one question for all of you guys to try now. Are you suggesting, Animesh, any method are you suggesting? बहुत तकलीफ हो रही है बैकग्राउंड नॉइज से. हाँ, कंसंट्रेशन ब्रेक हो रहा है. फॉरवर्ड इट टू सर. Why don't I block you today, Vansh Thakur? Huh? Why don't I block you? ये बिल्कुल वो वाला लेवल था क्रिकेटर्स जब when people you must have seen all those cricketers when they are playing they are on the striking end. सामने जो स्क्रीन होती है साइड स्क्रीन के सामने जब कोई आ जाता है तो they will not play the ball. No, people please just get aside then only will play the ball. है ना? No, there is some sound from the outside. I'm not saying that. There is some sound from the outside. But you don't have to go to the level that you're asking it to the class teachers that forward it to sir that there is some background noise coming. What do you want me to do? Shout from here. Guys, don't play. Go attend some online classes. Vansh Thakur, you're so lucky you're not in a physical classroom in front of me. Trust me. You're so lucky. अभी लंबी खामोशी है. वंश ठाकुर अभी कुछ नहीं लिखने वाला चैट बॉक्स में. And these are usually the kids who will not keep their mics on. They will not give the permission to the microphone to be unmuted. Yes, Anime. Yes. You were suggesting some easier method of solving this. Tell me, what's that approach? Okay. M1 plus M2. Okay, square. Chalo. Okay. Will get what? Will not get pi a square upon it. Because you will subtract a square minus pi a square by 8. This value does not come down to be pi a square upon it. And if I put the value of sigma as 1, then what you are suggesting is what I have done. So there is no difference in that method. You just have to take sigma value as 1. You can do that. It's not going to create any problem or any significant difference in the approach. Okay? क्या वंश कुछ लिखा है? अरे सर हमें लगा आप रीजॉइन करते तो साउंड चले जाता, हमने सोचा क्या पता ट्रिक्स काम आ जाए। हाँ, मतलब कॉमन सेंस को रख दिया हम लोगों ने कहाँ, पबजी के गेम के अंदर, है ना। चलो गाइस, yes, thank you Amal sir, thank you so much. Chalo guys, switching off the chat, enough talk, let's get back to work. Question for all of you guys, if you have understood the approach, a question is there in front of you, start reading. I'll set this question as a quiz. Okay, and it is the same approach but much easier than the previous one. You can see it by the options only, that the options are very simple, not ugly looking like the previous one. So the question exactly is in the same manner. You have a yellow disc whose radius is capital R, and in that disc you have cut a hole. Okay, so this is basically the hole, which is also of a disc shape of radius R by 4. So the earlier disc without any cavity, okay, the original disc has mass capital M. This is what the question also says. The original disc has mass capital M, original disc has capital R radius. From it, you have removed the disc of radius R by 4. Doesn't talk about the mass. You have to find out the mass of that portion. So the center of this hole, the hole that you have created, is at a distance R by 2 from the center of the original disc, which is your origin. Okay, so you have to find the center of mass of the remaining portion. Again, I'm telling you people, I will give you a bit of approach how you're supposed to go by this. So this whole cavity, assume that has mass m1 or had mass m1. The remaining portion of the disc will have mass m2. So already question has given you the value of x1, which is r by 2. You just need to find out the value of x2. So this time x1 is already so simply given to you. So only thing that you need to find out is m1 and m2, and your life is sorted in this question. Go by the approach m1 x1 equal to m2 x2, and consider center of the disc to be origin. Okay, that means what? This side is positive x-axis, this side is negative x-axis. According to that, all the options are negative, as you can see it in the diagram only, that the center of mass of the remaining yellow portion is going to shift to the left hand side, giving you people complete 90 seconds, and your time starts in 3, 2, and 1. Come on. Okay, final 10 seconds now. Oh my god. Oh my god. Let's see. क्या answer option B है? That majority of the people have answered it. Anyway, so everyone, if we say that the original disc has mass capital M, its radius is r, so its area is pi r square. This is what sigma is. This is the approach we go by. So the remaining, or rather sorry, the removed portion, जो portion हमने निकाला है, उसका mass m1 ले लेते हैं. Okay, और उसका area, the area of that part is going to be pi r by 4 square. R by 4 square. The radius is r by 4. Okay, that means what? Pi cancels. This, when you simplify, will give you m1 as capital M by 16. So 1/16 is the mass which has been removed. So the remaining mass m2 will be m minus m1. That means m minus m by 16, 15 m by 16. अब तक समझ आ रहा है? Is it understandable so far? I hope I'm not doing any mistake. Everyone, all good so far? Very good, thank you. Good. So we have the mass values. Done. Nothing else to do. From here, we will say that m1 x1 will be equal to m2 x2. x2 will be equal to m1 x1 upon m2. So m1 came out to be m by 16. x1 is already given to us as r by 2, and m2 is 15 m by 16. 16 gets cancelled, m gets cancelled. It is r by 2 by 15, which is r by 30. Okay, so you can see that the value came out to be positive because this derivation m1 x1 equal to m2 x2, when we did that derivation, we already considered that one of them is on the left hand side. So we considered this negative side, which naturally tells you that one of the mass has to be on the negative side. Okay, so what will be our answer as per the options? Obviously, our answer will be x equal to minus r by 2. This is what it is. Is this understood, everyone? Got it? Yes, Manav? Yes. Tell me. Mhm. What is sigma? What is sigma? What is sigma? Come again? What do we understand by sigma when we are using them in these questions? So, and if you have to mathematically express it, how will you? Mass by area, exactly. Right? Now, say you had a disk, okay? And if it is uniformly dense, this thing is uniform, yani constant. Okay? Which means what? If I cut this disk into half, the two portions, last time I also explained this part, the two portions will have different areas, different masses. But what will be same for both of them? Manav? Can I say their mass upon area will still be same? That's what density, right? So in this case, if I talk about the original disk, where was the center of mass of that original disk? Where would the center of mass of a normal disk would be for a disk? The center of mass of a disk, where do you think it locates itself? Seriously, this is a disk. Where is the center of mass of this disk? Use common sense. What do you mean by center of mass? Where would you do that for a disk? You are still confused on that? What you're speaking as 4r by pi is not for a disk. It's for a semicircular disk. So if I remove something symmetric such that the line of symmetry is x-axis, will the center of mass of this disk be shifted? Will it still be at the geometric center? Will it still be at O? If I remove this portion, will not be, right? It will be shifted above or below or left or right? Left, right? So this will be the location of the center of mass now, right? So that is the location that we are interested in finding with respect to the center of the disk. This is what we are interested in finding. So my approach is, if I fill this gap back, whatever I remove, if I put it back, can I say that the original disk will be formed again? So the center of mass will come back here, and that will be capital M mass. So that means if I look at this yellow portion as mass M1 and the portion whose location I'm interested in finding as M2, so can I say that if this is X1 and this is X2, M1 X1 should be equal to M2 X2 for a 2 mass system? That's what we have been doing so far in the question. Okay. Okay. Speaks over to sir that M is at origin. At origin, can we go with the logic of positive axis and negative axis so we get R by 30 to be? I didn't get what you're asking, class teachers. If you actually want to get the answer as negative, then you will have to solve it as M1 X1 plus M2 X2 equal to 0. Assuming that you do not even know that where exactly the center of mass of the remaining portion will come, that means what will be the location of M2. Here, when we approach it, we said that we know that M2 will be on the left hand side of center. It will be on the negative x-axis. So if you approach it with the thought that I don't know where exactly the location of M2 will be, then you will have to approach it as M1 X1 plus M2 X2 equal to 0. Then your answer will come out to be negative because you will take this side negative. On the right hand side, you will get M1 X1 equal to minus M2 X2. And that will be a proof that when you remove something on the right hand side of the disk, the center of mass will shift to the left hand side, which is the negative side. Okay, guys. Remember, mathematics is a tool. How you want to use it always on you. Physics does not bind you to always use mathematics in a given way only. You can always approach it in the best suitable way for you. Okay, remember that. Our approach should be easy for us to understand so that we are able to solve questions when we are applying the mathematics that is applicable in multiple ways. Okay. Chalo, guys. So this is what we were supposed to solve in the previous class itself. Now we'll move our discussion towards the motion of center of mass. That means what? Whenever we speak about a system of particles or an object itself, if that object starts to move, say this is that object, which is a disk, whose center of mass is at the center. If this disk starts to move, if this disk starts to move, can I say that its center of mass will also be moving along with it? Okay, right? So there is a possibility that center of mass can move. We will talk about possibility when center of mass may not even move. Okay, so let's get into the interesting part of center of mass. Yeah, so everyone, we already have spoken about the location of center of mass for multiple particle system. Okay, that means what? The location of center of mass is dependent upon the location of the different particles. Here we had only a single object. What if we have multiple objects whose center of mass is being written as M1 X1 plus M2 X2 plus M1 divided by M1 plus M2 like that? Okay, so if we say that your masses are not stationary, means to visualize this, visualize the solar system, and that too from a far away point. Just imagine it to be like that. You're observing the solar system. So solar system, different planets are moving with different speeds. They are located at different points with respect to each other and with respect to the sun also. Even if we consider sun to be fixed, right? Sun assumed to be fixed. The planets are randomly moving. Their velocities are definitely not same. Angular velocities are also not same. Basically, if you click a picture of our solar system today, and if you click a picture after 1 month, and then after 5 months, then after 1 year, you will find the locations of the planets to be very different. Definitely, these values of R1, R2, R3s will be changing even when the masses have not changed. So definitely the location of center of mass will change. So if we start writing the variation of R1, R2, R3 with respect to time, we will be writing it as dr by dt. What will be called dr by dt? It's nothing but rate of change of position of an object. And what is rate of change of position of an object? Is nothing but its velocity. That means what, guys? If we differentiate R1, R2, R3 with respect to time, then left hand side also will have to differentiate with respect to time. So dr1 by dt is velocity of the first particle. dr2 by dt is velocity of the second particle. dr3 by dt is velocity of third particle, and so on and so forth. And what is drcm by dt is velocity of center of mass. And what is there in front of you is the expression of velocity of center of mass of n particle system when you have multiple objects which are involved whose center of mass you are trying to find out. Okay, guys. So there is a possibility that some of particles may not be moving. So accordingly, you will write their velocities to be 0. If there are particles moving, you will write their velocities. Remember, velocities will be considered as per their directions because velocity is a vector quantity. If a particle is moving on x-axis, we will write its velocity to be I cap with a vector I cap. If there's a particle which is moving somewhere in xy plane, then it will have I cap and j cap. If there's a particle which is moving in a space, I cap, j cap, k cap, everything will be written accordingly. So overall, you have to now involve vectors, you'll have to involve calculus, you'll have to involve the laws of motion, you'll have to involve work per energy. As I said, now we are getting into physics where whatever we have learned so far, everything will be used here. So now we are focusing on the kinematics of multiple particles. They are randomly moving, and we are trying to visualize a point, which is the point where the entire mass of the system at any given point of time is supposed to be concentrated, and that is center of mass. Okay, now what if, guys, these velocities, if they are also changing, this was only location so far that we considered was changing. What if their velocities are also changing? Then what will happen? You will say that dv1 by dt will be the rate of change of velocity of the first particle, which will be a1. Similarly, dv2 by dt, that will be the acceleration of the second particle, right, everyone? So on and so forth. Similarly, we can say that dvcm by dt will be nothing but acceleration of center of mass. That means what, people? We can write down the acceleration of center of mass. Okay, in a very similar manner, that acceleration of center of mass will be m1 a1 plus m2 a2, like that up till mn an. As many number of particles are there. If there is only one particle, the acceleration of the body, and the acceleration of center of mass will be same, because then there's no way they can be different. But if there are two bodies, then the acceleration of the center of mass can be different than a1 and a2 also. Okay, guys. Okay, now just I'm asking a what do I say a question which will be related to something which we have learned earlier. What do we understand by product of mass into acceleration? What is mass into acceleration? It's force, right? It's the force. Can I say that m1 into a1 is the net force acting on the first particle? Can I say m1 a1 is the force acting on the first particle? Similarly, force on second particle, force on third particle, force on fourth particle, so on and so forth. That means it is net force acting on first body plus second body plus third body. I'm not saying that the forces are actually going to act. Some of the forces can be zero also. Okay, getting my point, everyone? And what is m1 plus m2 plus m3 plus m4 plus mn? Can I say that is the total mass of the system? Capital M. This is acceleration of center of mass. Let's take this mass here. What is this? Mass of the entire system into center of mass. Can I say f1 plus f2 plus f3 plus f4 vectorially is the net force acting on the system? Everybody? Is that how things work? Mathematically converge ho gaya sab kuch? Okay. Means what? Means what? If you have multiple particles that you are focusing on, they all are having different forces acting on them. Okay. So you individually find out their mass into acceleration value, or find out the value of f1 plus f2 plus f3, find the vector resultant of all of them. Vector resultant of all of them and divide by the total mass. It will give you the acceleration of center of mass. Why we are studying it actually is because from solving point of view, we will assume that all the forces are acting on the center of mass. We will say that all the forces which are actually acting on different point masses or different particles, let them act on the center of mass. Center of mass will behave like a point mass. It will have the same forces acting on it and will give you the results of the entire system that you are looking for. Got it, everyone? That is what this equation means. Okay, that is what it is. Force on center of mass is nothing but the net force acting on the entire system. That's what it is. Akul Gupta. Cool, everyone? Now, everybody. By the way, similarly, this equation that you see, the previous one, everyone, this one. What is mass into velocity? What is mass into velocity? It's momentum. So if you want to actually write this as well, this is nothing but momentum of the first particle plus momentum of the second particle, like that the total momentum of the system divided by the total mass. So it is nothing but the momentum of the system is actually the momentum of the center of mass, P net actually. So everybody, if the center of mass is not moving, if your center of mass is not moving, say, pay attention now to this part. If your center of mass is not moving, its velocity is coming out to be zero. That will mean that your location of the center of mass is not changing. Okay, that simply means its location is unchanged. But that does not mean that R1, R2, R3 will also not be changing. Means what? If you have, just imagine this part, guys. Just imagine this part. You have a ball which is falling towards the earth, and this is earth. This is mass m1, this is mass m2, and this is moving with a velocity v1. Maybe earth is not moving only. Maybe earth's velocity is zero. So you see that, in fact, in this case, assuming that you have not earth, let me consider a body which is comparable size of mass m2. This is moving with a velocity v2. They are both moving because of the mutual force of attraction. They are moving because of the mutual force of attraction. They are applying force on each other, and they are moving towards each other. Okay, guys. So what will happen here? It may so happen that the center of mass will have its velocity coming out to be zero. This may so happen. And when will this happen? Say for a two mass system, if I say the velocity of center of mass is m1 v1 plus m2 v2 divided by m1 plus m2, if this is zero, then that simply means what? m1 v1 plus m2 v2 equal to zero. What does that supposed to mean, guys? What is m1 v1? Momentum of the first particle, momentum of the second particle. Their resultant value is coming out to be zero. Have you ever heard about a law called as law of conservation of momentum? Have you guys ever heard about law of conservation of momentum? If you have not, then this is what it is. If you start writing this part, okay, so we have already got this thing. We will be reaching towards law of conservation of momentum in about 10 minutes from now. मैंने सिर्फ उसका एक ट्रेलर दिखाया अभी. बहुत interesting topic है law of conservation of momentum. Okay, those who are followers of Rajnikant Institute of Technology, they will be offended. They will definitely be offended because Lord Rajnikant does not believe in law of conservation of momentum. But Hollywood movies, yes, Hollywood movies respect the law of conservation of momentum. And today I'm going to suggest you guys two Hollywood movies, which if you get time, you can watch. If you have already seen, you will understand the physics behind it. Okay, okay. So emotional mat ho jao. Let's see some example, everybody. Okay, we will speak about that. Yes. Okay. Chalo, switching off the chat, stop writing anything in the chat box, in the comment box, in the doubt panel also. Keep calm and pay attention. Problem solving starts from here. Okay, guys, बहुत सारे questions solve करने. Already 1 hour is gone. Let's focus. So everybody, the question says that you have two particles of mass 2 and 4 kg. They are approaching towards each other with acceleration 1 and 2 meters per second square, and that too on a smooth horizontal surface. Find the acceleration of the center of mass. As simple as that. So acceleration of the center of mass is nothing but m1 a1 plus m2 a2 divided by m1 plus m2. Now the only thing is, guys, one of the particles is moving to the right hand side, the other particle is moving to the left hand side. That means I have to put the acceleration of the other mass to be negative. Okay, so the first mass is 2. And here what I'm going to take this as m2, this as m1, so that my answer comes out to be positive because all the options are positive. That's why. Okay, guys. So m1 is 2, acceleration is -1. Okay, I'm considering m1 to be 4 kg and m2 to be 2 kg. So the acceleration of 2 kg mass I'm considering as -1. Why am I considering -1? Because one of them has to be considered negative because of the direction of motion. Okay, they're approaching. Approaching means they're coming towards each other. The other mass is 4, its acceleration is 2. Okay, 2 ka acceleration 1 meter per second square, 4 ka acceleration 2 meter per second square. So numerically I'm right, and the mass 2 plus 4. So this is -2 plus 8 divided by 6. That is 6 by 6, or simply 1 meter per second square. That's the acceleration of the center of mass. Okay. So sir, if I would have not taken m1 acceleration to be -1, and if I would have taken this as negative, my answer will come out to be negative then. But you can see that all the options are giving you the positive result. That means they're talking about the magnitude of it. If they would be so sophisticated that they want you to actually talk about the direction also, they will give you the diagram also. They'll give you the information appropriately to get the answer positive or negative as well. Okay. So now question for all of you guys. Have a look. You have a system of two identical particles. Identical. Both have same mass. One of the particles is at rest. The other particle has acceleration a. What do you think will be the acceleration of center of mass? Giving you 45 seconds. Time starts in 3, 2, and 1. Come on, people. Last 10 seconds. It is actually an oral question if you got the hang of the formula. Okay, and the time is up. Arey yaar, why to be in a hurry when you are answering it incorrectly? Just to have your name in the fastest finger list of no use. Okay, so acceleration of center of mass, first mass is m, acceleration is 0, second mass is also m, acceleration is a, and mass is m plus m, writing it as 2m. So this is 0, this is ma by 2m, mm cancels, you have a by 2, that's your answer, a by 2. Okay, next question, two particles of mass 1 and 0.5 kg, they are moving also in the same direction, that too with speed 2 and 6 meters per second respectively, that too on a smooth horizontal surface. You have to find out the speed of the center of mass, velocity of the center of mass will be how much, you have to find out, giving you 1 minute, and your time starts in 3, 2, and 1, straightforward, m1 v1 plus m2 v2 upon m1 plus m2, come on, come on, come on. Fitafat formula application questions, all of you. Hmm. बेटर पिछली वाले से बहुत 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 बेटर ओके सो m1 v1 plus m2 v2 divided by m1 plus m2 so this is 2 plus 3 that is 5 by 1.5 or you can say it is 50 by 15 or you can also say it is 3 by 2 matlab 10 by 3 that is 3.33 meters per second okay good chalo guys now as I said we will be talking about the law of conservation of momentum actually an important moment in our journey of mechanics this is the final law of what should I say the final fundamental law in mechanics we have a lot of physics to study but this is the final fundamental law इसके बाद जितने भी laws होंगे वो इन्हीं तीन laws के आसपास घूम रहे होंगे what are the three laws the first one was the set of laws of motion the three laws of motion considered to be one set of laws second is law of conservation of energy and third one is the law of conservation of momentum you can practically solve any question of mechanics from these three laws where dynamics is involved okay not kinematics where dynamics is involved okay so people I've given you the trailer already that if you have the net force acting on the system to be zero then the center of mass acceleration will also be zero and that does not mean that individual particle accelerations have to be zero but center of mass the net forces acting on it should be equal to zero and if that happens guys we can say that the overall momentum of the system when we try to write this okay I will explain it here only if we write the acceleration of center of mass which is nothing but in fact if we say that acceleration of center of mass if it is zero we say that the net force acting on the system is equal to zero and what is F net acting on the system it is nothing but the rate of change of overall momentum of the system right everyone this is zero okay or you can say if you want to understand it in differentiation form the rate of change of momentum is zero and whenever the differentiation of quantity comes out to be zero we say that the quantity must be a constant not zero that quantity should be a constant if momentum of the system is constant then the value of the change of momentum which is giving you the value of the force acting on the system will be equal to zero means you have to look at it just opposite if the momentum is constant its differentiation is zero which means the net force acting on the system is zero which means center of mass ka acceleration is zero or you can say that p1 plus p2 plus p3 up till n number of particles which are there if you will do the vector sum not just numerical values you will have to write the vector resultant of the momentum that value will always come out to be zero in such case what is the condition remember the condition aadha adhura yaad nahi rakhna this is the condition okay this is the condition if acceleration of center of mass is zero which means if the net force acting on the system is zero then this happens guys this is what is written here okay that doesn't mean that the particles are at rest. Particles are moving. They may be moving. They may be moving because of a force which is applied by all of them on each other. Means what? I'll give you a very beautiful example now here. That maybe you have mass m1 and you have mass m2. The force applied by m1 on m2 is F, and the force applied by m2 on m1 is also F. Okay. And if I have to write the vector form of it, one is F, other one is minus F. What do we call these forces? What do we call these forces? There is a specific name given to such situations according to laws of motion. We call them action-reaction pair, right? So everybody, if we consider now, बहुत ध्यान से सुनना, everyone, बहुत ध्यान से सुनना. If we talk about this as the system, बहुत ध्यान से सुनना. If this is my system, can I say there is an external force acting on my system because of m2? There is an external force acting on the system. So can the momentum be conserved? No. Momentum cannot be conserved if only m1 is my system because there is an external force acting on my system, right everyone? But if we consider say m2 as my system, if this is my system, is there an external force acting on m2? Is there an external force acting on m2 the system? Yes, m1 is applying that force. So can the momentum be conserved? No, there is an external force acting. Okay? But now listen to this part. This is where the beauty is. Now consider this as my system. What is F net on the system? F minus F equal to 0. What do you say? What do you say? That acceleration of center of mass will be 0. Does that mean my two masses will not move? Does this mean that m1 and m2 are stationary? No, they are not stationary. They are moving. They are moving towards each other. But compulsorily, if one is moving to the x-axis side, other will move to the minus x-axis side. They will approach each other or they will go away from each other. Are you getting my point, everyone? Are you getting here what is happening? So this is the point that I'm trying to justify that kinetic energy of the system is not constant. It is not necessarily constant. Kinetic energy is changing because the masses are moving. They're accelerating. M1 is accelerating, M2 is accelerating, but M1 plus M2 is not accelerating. M1 plus M2, its acceleration is 0, which means the momentum of the system is constant. If it was 0 earlier, now also it will be 0. Okay, guys? So this is what it is. One more thing, everyone. At times, there might be only one direction or one of the axes on which the net force acting will be 0. Means what? There might be unbalanced forces acting on y direction or z direction. But if, say, there is only one of the directions where the net force acting is 0, say, like in x-axis, the net force acting is 0. So you will say that along that axis, the momentum is conserved. Not necessarily the entire system. On all the directions, the momentum has to be conserved. In a given direction also, you can do that. Right, everyone? So acceleration of the system in x direction will be considered to be 0 in that case. You will say only x component of acceleration is 0. So only the x component of velocity will be constant. And only the x component of the net momentum will be constant. Okay, we will obviously see this practically applied mathematically also in the problem solving that we will see. Okay, so we have done this, we have seen this already. This is basically what we call as the law of conservation of momentum. Okay, this is called law of conservation of momentum. Okay, got it, everyone? That वाला part का क्या मतलब है? So not understood that वाला part. ये वाला, what do you mean ये वाला part? ये वाला part हो सकता है. अरे in fact you guys, best example. Do you people remember this motion? We have studied this. याद आया? Projectile. Do you remember in projectile motion there was a force acting on the body, mg, always and always. But do you people remember the x direction velocity always remained constant, did not change? Remember? So the momentum along x direction during projectile motion remains conserved. Why? Because there is no force acting on the x direction on the body. Got it? Mass से multiply कर दो. So if you multiply it by mass, it becomes constant. Understood now? This is what we meant. That in a given axis, okay, fx is equal to 0. This is fy. Cool. Chale? Okay, yes, we have come a long way. Now the practical examples of law of conservation of momentum. Very beautiful situation. Have a look at this. This is practically the law of conservation of momentum at its best. Initially, the cannon and the ball inside, you can also consider it to be like a gun and a bullet situation. The cannon and the ball inside are initially at rest. So their center of mass is also not moving. The moment you fire the cannonball on the left hand side, look what happens to the cannon. You can talk like this also, that if the bullet goes out of the gun, the person who's shooting will always feel a recoil, right? Why this recoil is happening, guys? Because the force applied on the cannonball is F, and the force applied on the gun, okay, the force applied on the gun is minus F. Or you can look at it this way: the force is applied by the cannonball, or you can say a bullet wala situation. So you can say that the force is applied by the gun on the bullet in the left direction, and the same force is applied by the bullet on the gun on the right hand direction. So if you consider both of them as a part of the system, the net force acting is 0. So their momentum has to remain conserved, and the velocity of the center of mass initially is 0. So finally should also remain 0. That's why, ध्यान से सुनना, when one of the mass goes this side, it gains a momentum of minus m1 v1. The other mass has to go on the right hand side, gaining momentum m2 v2, and the initial momentum and the final momentum both have to remain 0. Initial was 0, and you can say that this is the final momentum that I have written. So initial was 0. So this happens when you have m1 v1 equal to m2 v2. That is why the cannonball has a mass which is less, but the velocity is high. Why? You can see that the gun, it has a very big mass, so it comes relatively slower, but comes back always. They will always move in the opposite direction. Another example: if you are on a boat and say the boat is now almost on the bank of the river, and you get down the boat, or say a skateboard, you get down on the skateboard. The skateboard will always go back. The boat will always go back when you get down the boat. Are you guys getting this? This is practically the law of conservation of momentum in front of you all. Okay. Similar is the reason of firing of your rocket. When the rocket is launched, there is a lot of fuel which is burning inside. Okay. There is a lot of fuel which is burning inside. When the burning fuel happens, there is a lot of exhaust gases which come out of it. Those exhaust gases, when they come out, they are being thrown out by the body of the rocket. So the direction in which the exhaust gases are coming out, this is the direction in which your exhaust gases are coming out. So these exhaust gases are experiencing a force F, while these exhaust gases are going to apply an opposite force on the body of the rocket, which is minus F. So if you consider them as one of the systems, then F net is equal to 0. Because of that, the rocket keeps on going up. Okay? Cool. What happens if this law doesn't exist? Seriously. Then physics would be different. Okay? Another example here. You can see that at a time only one of the balls has momentum. The other ball does not have the momentum. It is only transfer of momentum happening. Law of conservation of momentum, because forces are applied internally. There is no external force acting. Okay? Now, everyone. Third law से भी related है, obviously. When there are two objects only. Right. Now, people, there is a movie you might have heard about. Okay? Movie is, can you guess the name of the movie? Yes. The name of the movie is Gravity. The name of the movie is Gravity. One of the most beautiful movies because of the law of conservation of momentum. Okay, so I will tell you the story, those who might not have seen the movie. Okay, yes. So switching off the chat so that we listen to the part which is important here with respect to the law of conservation of momentum. So what happens in this scene? This astronaut, Sandra Bullock, is the name of the movie star. So she has to move from her spaceship to an international space station, because in order to move when you are initially at rest, an object will remain at rest until unless an external force is applied on it. She is at rest. Nobody is there to apply a force on her body. Her spacecraft does not have any fuel left. So without fuel, there is no combustion, no exhaust gases, nothing moves. So she decides to take what is in her hand right now in this graphic image file that you see. She has a fire extinguisher in her hand, and she just takes it and comes out of the her spacecraft. She opens up the fire extinguisher. You see that exhaust gases kind of situation is happening there. So the direction in which she wants to go, she will just point it in the opposite direction. Okay. So when she is putting it in a given direction, the gases are going, the exhaust gases from the extinguisher are going in a given direction, and she'll move in the opposite direction. This way she's actually navigating her direction of motion. And finally, when she's about to reach to the International Space Station, the entire, the compressed material which is there inside is gone. Nothing is left to come out. What she does eventually, she throws the fire extinguisher in a direction opposite to the direction where she wants to go. So what happens? If this is mass m1 thrown with a velocity v1, she's mass m2 will be gone in the direction opposite with a velocity v2. And that way she gains the momentum, goes in the opposite direction. In this entire process, whatever is the other object, if you consider, say, the fire extinguisher and the exhaust gases coming out, them and the astronaut as one system, the external force acting is 0. It's only trying to get a force from the other body. So one body moves, the other moves in the opposite direction. Try to watch this part of the movie if you guys have not seen this movie. If you have seen this movie, try to watch this part only. There's a 5-10 minute part in the movie itself. Okay, cool. Another movie. Any guesses? Another movie. Any guesses? जहाँ पे ये है law of conservation of momentum. Not Interstellar, though it is there in. अरे what just happened? Do you guys see anything? मुझे कुछ नहीं दिख रहा. तुम लोगों को दिख रहा है कुछ screen पे? You don't see anything, right? Just a second. Just a second, यार. Do you guys see now? Everyone? Guess the movie. Yeah, this is The Martian. This is the story of a scientist who's stuck on Mars, how he's going to escape the Mars. Okay, so in this movie, when he is being saved by his fellow astronauts, okay, so when he has to lift himself, see his left hand, something is coming out of it. Those are the, you can say, the gases which are there inside his suit in order to create that atmospheric pressure. Okay, so in order to move, he just punctures his suit and tries to balance the vector of momentum. So exhaust gases come out, he moves in the opposite direction. Again, law of conservation of momentum. Okay, Iron Man also, the way Iron Man actually moves is the same thing. Okay, everyone. So just wanted to give you guys a feel of it. We will not stop here. We will not do a side chat here. Let's go forward and switching off the chat. Okay, keep your doubts, keep your extra thoughts with you. We will be discussing them at the end of the class. Okay, everyone. Let's solve a few questions quickly, everybody. So everyone, have a look at this. Question says, this is an example. Two blocks A and B are joined together by a compressed spring. So you have two blocks, they have a spring between them. You compress the spring, or the spring is already compressed, and you put it on a frictionless surface. You put the entire system. Okay, two blocks are actually connected by the spring. Spring is compressed. You put the entire system on a surface. So when the system is released, that means you put the system on the surface and you remove your hand. Obviously, the spring is compressed. It will try to come back to the natural length. So it will throw the two blocks away. It will push the two blocks away. So this block at this instant is moving with 15, and the block A is moving with a speed 10 meters per second in the opposite direction, unequal speeds. Which option do you think will remain correct here? Guys, can I say that as a system, there is no external force acting in the chat box? There is no external force acting in the system. Why? Because if you talk about the two masses, who's applying the force on the two masses? Can I say it is the spring which is applying the force on the two masses? And the spring will apply the force on both the directions. We'll try to push both the blocks in the opposite direction. So what is the net force acting in the system, everyone? What is the net force acting in the system? Can I say it is 0? Right? Yes. So if it is 0, then initially when you placed the system, nothing was moving. So center of mass initially was at rest. Will it still remain at rest? Will it still remain at rest? Yes, it will still remain at rest. Why? Because the net force acting on the system was 0 earlier also, later as well, and the mass will remain stationary, the center of mass. The masses are moving individually, but the center of mass will not move. Okay. Quickly, a question for all of you. An astronaut floating in space has a total mass of 201 kg, including his weight and his equipments. He throws a 1 kg wrench with a speed of 10 meters per second. The gravity situation. What is the resulting speed of the astronaut? Okay, the momentum has to be conserved. Initial momentum of the system is 0. Initial momentum of the system is 0. You have to think what will be the final momentum and how will you write it. Giving you guys 60 seconds, and the time starts in 3, 2, and 1. Come on, people. Now we only have questions to solve. Okay, theory for the day is done. Okay. So everybody, if the person and the wrench, say he has a wrench, which is like this, I don't know how it looks like. So this is the wrench. Okay, actually wrench doesn't look like this. Wrench is something that you use to it's basically like a nut driver. Okay, something that you want to, the bolt and nut you want to tighten up. Okay, and when this guy throws it, okay, when this guy throws it, this goes with a velocity v1, and he himself will go with a velocity v2 in the opposite direction. This is m2, this is m1. So initial momentum is 0. So final momentum should also be 0, right, everyone? So 0 will be equal to m1 v1 minus m2 v2. Why am I writing minus directly? If you don't want to write minus, that's fine, guys. You can write it like this also. Don't get confused, okay? When we write m1 v1 minus m2 v2, we always, in such cases, take the direction opposite of one of the objects in account. If you do not want to take that into account, you have to write the equation vectorially and say that the final momentum of the system will also be 0. So from here, v2 vector will be equal to minus of m1 v1 by m2. This naturally gives you minus sign, which basically suggests that v2 is in the opposite direction. Okay, so we only need the magnitude. So v2 will be equal to m1, which is 1 kg wrench, its velocity that is 10, and the mass of the remaining thing that is 200. So this is 1 by 20 meters per second, which is 0.05 meters per second. That's the answer. Okay, cool. Now let me show you guys a question from something wrong has happened today. You know what wrong has happened? I've actually made changes to the questions, and those questions are not, the changes are not visible here, by the way. Means the changes didn't get saved. That's what has happened with me today. Yeah, so what is it that I want to write here is that this is a question from JEE Advanced 2011. This is a JEE Advanced question. Okay, let me pick the figure to explain you guys the question. Okay, yeah. So question says that, very filmy theoretical situation, guys. It says that you have a bullet. This is a bullet whose mass is 0.01 kg. It is moving with a velocity v, and it is going to hit this mass capital M, which is placed on a pole. Okay, that capital M mass is a ball, so maybe a metal ball, and it is of mass 0.2 kg. So when the bullet has hit the ball, both the objects eventually fall down. This is where the ball falls, and this is where the bullet falls. Okay, this is 20 meters where the ball falls, 100 meters where the bullet falls, and the height of the pole where the ball was actually placed is Sorry. Are you guys able to see this? Everybody is able to see this, right? Very good question. ये डाउट है ना, बहुत सारे लोगों पे डाउट है ना? टोटल मास कितना था पहले? टोटल मास कितना था? 201, इंक्लूडिंग व्हाट? थिंग्स दैट ही वाज होल्डिंग आल्सो. तो अगर 1 किलो फेंक दिया तो कितना बचा? Okay. Okay. Cool. Shweta, you can ask me the doubt at the end of the class once again. Okay. चलो guys, switching off the chart. Approx नहीं लिया है वहाँ पे, exact है वो शिवम. ठीक है guys. So we have a bullet which is moving with a velocity of v, which is unknown, वही पता लगाना है. There is a ball which is placed on a pole of height 5 meters. Okay. And once the bullet has hit the ball, okay, the ball hits the ground 20 meter ahead, while the bullet goes 100 meter ahead. Question is asking us to find out the velocity with which the bullet was moving. Okay. And initially, obviously, the ball was at rest. So one thing before I solve this question or any question after this, for all of you guys to identify when to apply law of conservation of momentum and when not, there are two definite situations where you have to apply law of conservation of momentum. One, when things are colliding. When things are colliding, आंख बंद करके without any hesitation apply law of conservation of momentum. Obviously, in the direction where the bodies are hitting each other, at least there. Okay. Secondly, when something explodes into multiple objects, there will be questions following from here that there is an object which explodes into 3 parts, 2 bodies, multiple things, a firecracker breaking down into multiple bodies. Then also you have to apply law of conservation of momentum. Okay, everyone. So in this question, we have to find out the velocity with which the bullet is going. So when the bullet will hit the ball, and say it is not going to penetrate it, it's just going to hit it and the 2 objects will fall eventually down. So, or maybe the bullet penetrates the ball gets some velocity, falls down, and bullet eventually moves ahead and finally falls down. That's the situation. So the thing is, everyone, bullet applies a force on the ball applies a force on the bullet. That's the situation. This is bullet, this is ball. When they collide, the ball experiences a force forward, the bullet experiences a force backward. The system has net force acting on the two, and that too in x direction to be equal to 0. Only in x direction I'm talking about, not in the y direction. Okay. So everyone, along x direction I'm going to apply the law of conservation of momentum. Okay. Why only along x direction? Because along y direction there is an external force acting. What is the external force acting on the y direction, everyone? Mg. So that's why along y direction the momentum is not conserved. Okay, people. So along x direction, earlier the bullet of mass m is moving. Its velocity is v. Capital M mass is the ball. What I'm writing, by the way, I'm writing here. Let me first clarify that part. What I'm writing here is the initial momentum of the system. I'm saying it is going to be the final momentum of the system. Both of them are going to be same, but in which direction? X direction. Okay. So everybody, mass of the bullet, its velocity initially. Mass of the ball. What is the velocity of the ball initially? Before the collision, it is 0. Okay, this should be equal to mass of the bullet just after the collision. Just after the collision, bullet goes with a velocity v1 and the ball goes with a velocity v2. Okay, so the bullet of mass m goes with a velocity v1 and ball of mass capital M goes with a velocity v2. Okay, everyone, this is before collision, this is after collision. Cool. Okay, so we need to find out v1 and v2. Masses are already given to me. Now people, look at the distance which they are traveling, and already the height has been given. Question has said that this is 5 meter and there is an object which has a velocity, say v1, and it is following a parabolic path falling here. Obviously projectile motion ho raha hai. And how much, say 20 meter has been traveled, or say x has been traveled. Forget about anything else. H is the height by which things are falling. Okay, everyone. So the time taken by the body to fall is under root of 2h by g. Yaad aaya kuch? This is horizontal projection. Under root of 2h by g. Are the two objects falling by the same height? Yes. Are the two objects falling by the same height? Yes. How much is that? 5 meters. G value 10. How much time do we get? 1 second. The two objects will take 1 second to fall, both of them. How will I calculate x? I will calculate it as v into t. So let's calculate x1, which is given to me as 100 meters. This is basically bullet. Bullet ke liye 100 meter. Its velocity v1 I'm interested in finding. How much is the value of time? It is 1 second. So what is the velocity of the bullet after collision? 100 meters per second. Are you guys following this? Aa raha hai samajh mein? For the ball, the distance x2 is given to me as 20 meters. Velocity v2, it also takes 1 second to do that. So v2 comes out to be 20 meters per second. Okay, everyone. So we've got the value of v1, we've got the value of v2. Do we have the mass values already? Yes, we have the values of masses. So mv is equal to mv1 plus capital M v2. So small m ka value is 0.01. I don't like to write things in decimal code, sorry. That's my personal way of writing things. I always write them in ratios. So 1 upon 100, v is something which we want to find out. This is 1 upon 100. v1 came out to be 100. Mass of the ball is 2 by 10. Its velocity is 20. Okay, cool, everyone. This cancels. V by 100 is equal to 1 plus 4, that is 5. V comes out to be 5 into 100, that is 500 meters per second. That's the answer. This is the speed with which your bullet must be moving before the collision, and precisely and well deserving a JEE advanced question. Definitely projectile involved, kinematics involved, remember, and center of mass. और अभी एक और chapter पढ़ा नहीं है, collision, that is also involved. What will follow? So that is why momentum concept, exactly, law of conservation of momentum involved. The diagram was given in the question. This diagram was given in the question. Okay. This is how. That's why I said from this chapter onwards you can expect questions which are technically, practically the questions which you expect in the examinations. ठीक है. Real JEE physics से पहले भी चल रही थी, पर real JEE physics is now. ठीक है. Shall I, everyone? Questions for all of you will not be as challenging as this one. Okay, easier questions. Okay, now as I said, whenever something is exploding, also you will have to apply law of conservation of momentum. So a bomb of mass 16 kg is at rest, initially at rest. So what is the initial momentum of the object of 16 kg mass? What is the initial momentum? 0. Okay, this should also be equal to final momentum. But the thing is, this 16 kg mass is exploding into two masses. 1 is 12 kg. So guys, if 12 kg mass goes to the right hand side with a velocity v1, the remaining 4 kg mass, where do you think it will go? It has to go in the opposite direction. This is something that I expect you people to always be able to figure out. So this is going to be 4 kg with a velocity v2. Question is asking us to find out the kinetic energy of the other mass. That means iska kinetic energy pata lagana hai. Okay, giving you all 60 seconds and the time starts in 3, 2 and 1. Okay, even if people are responding answers in the chat box, don't believe that is right, because they are not the only people who can solve it, and that definitely doesn't mean if there is something written in the chat box that's the right answer. Okay. Okay. So basically, the mass of the object is given. If you get the value of its velocity, you're done, right? Then it's done. Question is not a problem after that. So already you can see that the velocity v1 is given as 4 meters per second. So if initial momentum is 0, okay, if initial momentum is 0, final momentum is going to be 12 kg mass into 4 meter per second velocity, and 4 kg mass and velocity minus v2. I'm writing minus v2 so that I get the value of velocity positive, okay, or rather it's numerical value only. So v2 comes out to be 12 into 4 by 4. That means it is 12 meters per second. Itna आसान. 12 kg का velocity 4 है तो 4 kg का obviously 12 होना पड़ेगा, so that they have equal momentum. ठीक है, that's it. You have the mass, you have the velocity. Just find out the value of half mv square. Half mass velocity square 288. ठीक है, everyone. Now this one, a bullet of mass 10 gram moving with 100 meters, 300 meters per second hit a block of ice of mass 5 kg and drops dead. Drops dead means what? Comes to rest. So इसके लिए भी मैंने diagram बनाया हुआ था, but again I don't know, something has happened today with the platform that it hasn't saved my changes. So this is mass m moving with a velocity u1. This is mass m2. Its velocity initially 0. This is ice. Okay, that is obviously bullet. So after that, the bullet of mass m1, mass m1, its final velocity is 0, while your other part, that is ice, it gains some velocity, that is v2. Question is asking us to find out the velocity of the ice block. v2 पता लगाना है. Giving you by 60 seconds once again, and time starts in 3, 2 and 1. Options ध्यान से देखना, सेंटीमीटर पर सेकंड है. Okay. Tamal sir, obviously we make changes in the prepare mode only, and when we make changes in prepare mode, they get saved. But something might have happened. In prepare mode, all the changes that we make gets stored. Come on, people, just conserve the momentum, because when two objects collide, they apply force on each other. The net force on the system becomes 0. Momentum remains conserved. After the class, when you go through these slides, try to think on this thought. Try to think on this thought that why the net force acting is 0. Why the net force acting is 0? How? Not why. How it is 0. It is 0, but how it is 0 is important. The two forces acting on the two objects cancelling out each other. Okay. When you will be able to figure it out in every question like this, you will always be able to apply the law of conservation of momentum in such questions. Okay, people. So m1 u1 plus m2 u2, which is 0, is equal to m1 v1, which is 0, plus m2 v2, which is non-zero. So this part is 1, this part is 1. v2 is m1 u1 by m2. Okay. So SI units may convert करेंगे, solve करेंगे. I'm not interested in doing the maths today. So m1 is 10 to the power minus 2 kgs, 300 meters per second. This is 0. This is 0, and 5 kg mass velocity v2. Simplify करने पर it comes out to be 3 by 5 meters per second, or 0.6 meters per second. You can say 60 centimeters per second. Okay. Good. Okay. Last question of the day. A body of mass 1000 kg is moving horizontally with a velocity of 50 meters per second. A mass of 250 kg is added. This is the third situation where law of conservation of momentum is added. When something is moving and you just gently place something from the top. When you gently place something on the top on a body which is already moving, you are not applying any external force. The two bodies will apply force on each other only. So m1 is given, v1 is given. M2 is going to be the total mass of the system. Remember that. Okay. And you have to find out the final velocity of the combined object. Okay, everyone. Initially, the mass is only 1000. Later on, the mass becomes m1 plus m2. 1250. Giving you 45 seconds, and the time starts in 3, 2, and 1. Come on, people. Last 10 seconds now. Time's up. Let's see. क्या बात है? Very good. Awesome. So guys, m1 u1 will be equal to m1 plus m2 v1, or just write v here u. Okay, so this is 1000 into 50 equal to 1250 into v. So v will be equal to 1000 into 50 upon this value. Okay, simplify करोगे, this value will come out to be 40 meters per second. Okay, guys. Yes, so this brings us to the end of today's session, power pack session, I say. This is the leaderboard. Congratulations to those who made it to the leaderboard today. Congratulations. Well, very well done. Okay. Keep it up. Keep it up. Keep going. This is for all of you. Your favorite rocket man coming on the screen in 3, 2, and 1. And I heard a great job. Another thing that you guys like. लो ये भी ले लो, खुश रहो तुम. Okay. और ये रहा final leaderboard. Before I switch on the chat, let me tell you this is the formal end of the class. Those students who do not have any doubts can leave the session now. Class teachers as well, if you are done explaining your doubts, you can also exit the session. ठीक है? Chalo. Leaderboard goes away in 3, 2, and 1. वेलकम टू जेपैप। यस, वेलकम टू जेपैप। सर आपको म्यूजिक सुनाई देता है क्या? नहीं यार, हमको नहीं सुनाई देता एग्जैक्टली। वही तो मैंने भी तो बोला था कि वो जो भी साउंड आती है मुझे तो सुनाई देती नहीं है, तो और बोरिंग लगता है मुझे वो। हेलो। यस रितिमान। 56। यस। टेल मी माय अप्रोच। यू वांट द वेलोसिटी एज वेल? देन हाफ एम वी स्क्वायर को करना है, so maybe calculation mistake, right? Okay. Vedantu rocket also follows the law of conservation of rhythm. सर मुझे कट कर देना सर, है मतलब? Yes, spring वाला question I can explain. So what is happening here, Shweta? You have two objects which are connected by a spring. Okay, and spring is initially compressed. That means there is some energy stored. If you consider this entire as a system, then nobody from outside is applying any force in the horizontal direction. It is spring which is storing the energy, will push the two objects on the two sides. Fx as in kx amount of force will be applied on first block, and kx amount of force will also be applied on the second block. Effectively, the net force applied in the system becomes zero. That's why the overall momentum of the system and the center of mass, their velocity becomes zero. That's why you can say that center of mass does not move. Okay. डोंट वरी कैप्टन अर्शद, अभी हमने कोलिजन पढ़ा नहीं है और अच्छे से समझ में आ जाएगा। ठीक है सर, अपनी दाढ़ी शेव करो फिर आपको हमें डांटते हुए फनी लगोगे। देन व्हाई वुड आई वांट टू लुक फनी? नॉन एकेडमिक डाउट है? यू हैव नॉन एकेडमिक डाउट? wait. Sir, then why do the two masses have different velocities? Because when we speak about acceleration, it is force upon mass. If they have same force acting but they don't have the same mass, they will not have the same acceleration, and if they don't have same acceleration, they may not have the same velocity. Okay Shweta? मुनीश, थोड़ा सा जोर से बोलना पड़ेगा तुम्हें। कभी भी टू डायमेंशनल ऑब्जेक्ट में हम मास अपॉन एरिया को कांस्टेंट करेंगे, जो तुम पूछ रहे हो ना। हेलो, थोड़ा जोर से बोलना पड़ेगा। नो, so if this entire disk had a radius r and this thing has a radius r by 4, what do they have same is the value of density. Okay, they have the same density. So for the entire disk the mass is m. For the area of the disk it is capital A, and what will be capital A? Capital A will be pi r square, right? Yes or no? Yes or no? Yeah, same thing. Now let's call this small circle to have mass small m. What will be its area? I'll say it is pi and the radius ka square, r by 4 ka square. Yes or no? Right, pi cancels, so m by r square is equal to small m by r square by 16. 16 will come here. R square and r square cancels. What do we get? What do we get? M. Respond quickly. Small m. 16 times the bigger one. मतलब something that you are removing is bigger than what has been removed. Okay. आया समझ में? You got it? That's how we do it. Yeah. Okay. सर अगर यूनिफॉर्म, सर अगर थिकनेस यूनिफॉर्म है और वॉल्यूम डेंसिटी यूनिफॉर्म है, कैन वी से सरफेस एरिया डेंसिटी भी यूनिफॉर्म होगी? एब्सोल्युटली वही कर रहे हैं हम लोग आलेख। एग्जैक्टली यही अज्यूम किया हुआ है दैट थिकनेस इज यूनिफॉर्म। ओके, यस अमन। 26 आ गए, बोलो। तो एक वेलोसिटी को माइनस लिखते हैं। ये फॉर्मूला वेक्टर के लिए ही लिखा जाता है, क्योंकि आ कहां से रहा है? मोमेंटम से आ रहा है, और मोमेंटम वेक्टर क्वांटिटी है, इसलिए ये कभी भी स्पीड के लिए नहीं लगाएंगे। ये हमने लगाया भी तो हमने एक्चुअली वेलोसिटी के लिए ही लगाया, और एक्चुअली स्पीड देकर के भी उन्होंने वेलोसिटी दी है, बिकॉज़ दे हैव गिवन द डायरेक्शन, तो प्रैक्टिकली वो वेलोसिटी दी है। वापस बोलो। जहां लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम अप्लाई कर रहे होंगे वहां न्यूटन्स थर्ड लॉ ऑफ मोशन नेचुरली होगा ही होगा, लेकिन जहां न्यूटन्स थर्ड लॉ ऑफ मोशन लग रहा होगा वहां हर बार लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम यूज करेंगे वो जरूरी नहीं है। मतलब ये कि जैसे मैंने आज जो पहली सिचुएशन एक्सप्लेन की थी, दो ऑब्जेक्ट एक दूसरे पे फोर्स लगा रहे थे, ये वाला, तो यहाँ पे मैंने बताया था कि अगर मेरा सिस्टम सिर्फ इतना सा है m1, तो m1 पे लगने वाला जो फोर्स है F, वो एक्सटर्नल फोर्स है। तो अगर m1 मेरा सिस्टम होता तो लॉ ऑफ कंजर्वेशन ऑफ थर्ड लॉ ऑफ मोशन तो लगा है सिस्टम में या क्वेश्चन में, सिचुएशन में, लेकिन m1 अगर मेरा सिस्टम होता तो लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम नहीं लगता। फिर क्यों नहीं लगता? क्योंकि उसका एक्सटर्नल फोर्स जीरो नहीं है। तो मेरे चॉइस ऑफ सिस्टम पे डिपेंड करेगा कि लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम लगने वाला है कि नहीं लगने वाला है। ये है सबसे बड़ा इंटरेस्टिंग पॉइंट अबाउट लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम। द चॉइस ऑफ सिस्टम इज वेरी क्रूशियल, देन ओनली द मोमेंटम रिमेन्स कंजर्व्ड। सो दिस इज अ वेरी वेरी इंपॉर्टेंट लाइन, ये जो लिखी थी यहाँ पे, if f net is equal to 0 is very important. Okay, good. Right. कहाँ गया साइश? Sir, can magnetic repulsion be used for rocket as the electricity also conduct magnetism of big metal plane into ground? कहाँ से पढ़ के आ रहे हो तुम? कौन सी क्लासेस लगा रहे हो भाई? अलकायदा इंस्टीट्यूट ऑफ टेक्नोलॉजी? हाँ, वाई मतलब वाई। यस विहान, यस शूट। गुड इवनिंग। हाँ, शुरू करें। कौन सी स्लाइड से शुरू करें? हाँ हाँ हाँ, हम वीडियो देखेंगे। आएगी वो सिचुएशंस भी, आएंगी, बिल्कुल आएंगी। अब नहीं पड़ेगी, अगले अगले सेशन से ही सब कुछ बदल जाएगा। अगले सेशन से सब कुछ जनरलाइज हो जाएगा, कहीं भी जाने दो ऑब्जेक्ट्स को। और जरूरी थोड़ी है कि एक लाइन में ऑब्जेक्ट मूव करें हिट करने के बाद में, वो हिट करने के बाद में ऐसे भी तो जा सकते हैं, जैसा कैरम बोर्ड पे होता है। वो भी पड़ेगी। आज तो शुरुआत है ना, तो आज तो बेसिक से शुरू करेंगे। अभी और 3 सेशंस हैं जहाँ पे हम डिफरेंट टाइप्स ऑफ कोलिजन पढ़ेंगे। कोलिजन ऑन वन लाइन एंड कोलिजन व्हिच आर नॉट ऑन वन लाइन, व्हिच आर इन अ प्लेन। 2D 3D नहीं है सिलेबस में, पर 3D बहुत एक्सपेंसिव हो जाएगा पढ़ने के लिए। तीसरा हम पढ़ेंगे टाइप्स ऑफ कोलिजन में कि कैसे अलग अलग तरह से ऑब्जेक्ट्स कोलाइड करते हैं, कोलाइड करने के बाद में बॉडी भी बन सकते हैं दोनों। जैसे वो आइस वाला क्वेश्चन था, आइस और बुलेट वाला, उसको बुलेट अगर आइस के अंदर ही रह जाए तो दोनों एक ऑब्जेक्ट बन के आगे चले जाते हैं। तो वो सिचुएशन भी पढ़ेंगे। अरे यार एक मिनट, साइश कुटिया क्लास से ही चला गया। ठीक है, हाँ और बोलो। हाँ, अच्छी बात है ना, तो पढ़ने दो, अच्छी बात है। अपन भी पढ़ेंगे यार, जब जरूरत पड़ेगी अपन पढ़ लेंगे, टेंशन मत लो। हम्म, कुछ और ऑप्टिकल इंजीनियरिंग क्या होती है? क्या करते हैं उसमें? तो ऐसा कोई अंडर ग्रेजुएशन का कोर्स नहीं होता। वो बेसिकली होता क्या है, जैसे बहुत से स्टूडेंट्स साउंड इंजीनियरिंग भी बोलते हैं कि सर मुझे साउंड इंजीनियरिंग करना है। तो देयर इज नो अंडर ग्रेजुएट कोर्सेज ऑन साउंड इंजीनियरिंग, लाइट इंजीनियरिंग और एनी ऑफ दिस सॉर्ट। दीस आर एक्चुअली स्पेशलाइजेशंस। और पोस्ट ग्रेजुएशन भी नहीं होता इन पे पोस्ट ग्रेजुएशन भी नहीं होता, मतलब एमटेक भी नहीं होता, एमएस भी नहीं होता इन पे। ये एक्चुअली बहुत निश और बहुत स्पेसिफिक फील्ड्स होती हैं जिसमें आप आगे जाके पीएचडी करते हो या आगे जाके और कोई रिसर्च करते हो। तुम आगे जाके कोई भी इंजीनियरिंग से स्टार्ट कर सकते हो वैसे तो। ऐसा कुछ कहीं लिखा नहीं है कि इंजीनियरिंग जिसमें डायरेक्शन में जाना है उसी से स्टार्ट होने के लिए कोई पॉइंट होना चाहिए। ऑल द इंजीनियरिंग इवेंचुअली कन्वर्ज है। बट स्पेसिफिकली बात करें तो यू कैन स्टार्ट विद अ डिपार्टमेंट इन मेजॉरिटी ऑफ द कॉलेजेस कॉल्ड एज इंजीनियरिंग फिजिक्स, व्हिच डील्स विद थ्योरेटिकल फिजिक्स। ठीक है। तो अभी आई थिंक अभी ऑल्सो धीरे धीरे समझते जाएंगे हम लोग ये सारी चीजें। हम्म, तो धीरे 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 एज द टाइम पासेस हमें खुद भी बहुत आइडिया लगने लगता है। दैट्स ऑल। ओके। पैरेलली थोड़ा टाइम निकालना पड़ेगा, स्पेशली द टॉपिक्स व्हिच आर नॉट पैरेलली डन इन वेदांतु। नॉट ऑल राइट। हाँ, ये केमिस्ट्री फिजिक्स में भी हो रहा है। हाँ, तो देख लेना, इफ थिंग्स आर, आई एम श्योर फिजिक्स में भी मैच हो जाएगा। अगर इस कुछ और चेंज कर ले वो बात अलग है, ऑर्डर ही चेंज कर ले, तो अदरवाइज तब वेदांतु में भी हम लोग टर्म 1 और टर्म 2 के ऑर्डर से ही जा रहे हैं। हम्म, अच्छा तो बहुत पीछे, बहुत पीछे भी तो, है ना? चलो, सब गुड, ऑल गुड। ठीक है, चलो, यप, राइट 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 राइट। ओके समझ बेटा, सबका नंबर आएगा बच्चों। यस समझ बेटा। लेकिन अब एको हो रहा है, एको नहीं हो रहा है ना, मुझे मेरी आवाज नहीं आ रही। हाँ ठीक है, ओके टेल मी, अब बोलो, शुरुआत करते हैं। रॉकेट वाला सही है, हाँ। कम अगेन। लिटिल मोर ऑफ का मतलब मैं समझ नहीं पा रहा। तो एक्चुअली जो इंजन है ना, जैसे अगर हम व्हीकल्स की भी बात करते हैं, व्हीकल्स जो हमारे व्हीकल्स होते हैं, टू व्हीलर, फोर व्हीलर, उनके इंजन का काम व्हीकल को आगे ले जाना नहीं होता। उनके इंजन का काम व्हीकल के टायर्स को घुमाना होता है सिर्फ। मतलब कहने का ये कि अगर टायर फ्रिक्शनल सरफेस पे है, रफ सरफेस पे, तो जब घूमने की कोशिश करते हैं तो अपने आप आगे चले जाते हैं। लेकिन अगर यही सिचुएशन फ्रिक्शन लेस सरफेस पे हो जाए, जो कि इमेजिन भी की जा सकती है कि अगर मान लो कार चलते 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 सडनली एक फ्रोजन लेक पे चली जाए, मूवी में शायद कभी हुआ भी होगा किसी मूवी में, तो कार रोटेट करती रहेगी, टायर रोटेट करता रहेगा, आगे जाएगी, ब्रेक फेल हो जाएगा एक्चुअली, ब्रेक लगाओगे ना। हाँ, और तुम ब्रेक लगाओगे भी तो रोटेशन ऑफ द टायर रुक जाएगा, लेकिन कार चलती रहेगी। तो इंजन में भी, मतलब रॉकेट में भी, अगर एटमॉस्फेयर ना हो, अगर एटमॉस्फेयर ना हो तो लॉन्चिंग के टाइम पे, जो इनफैक्ट एटमॉस्फेयर हो या ना हो, जो भी इंजन का काम है उसका काम डेफिनेटली फ्यूल को बर्न करना है, और बर्न करने के बाद में गैसेस को एग्जॉस्ट करना है, बाहर निकालना बहुत इंपॉर्टेंट काम है। वो बाहर निकलने का प्रोसेस इज द वन व्हिच इज मेकिंग श्योर दैट द रॉकेट इज गोइंग अप। So they are not providing a little more of thrust, it is basically providing the same amount of thrust which is being applied on them. हाँ. Mm-hmm. Just a minute. Yes, Harshan, there is an engineering called as electronics and communication engineering. ECE is what they call them. Yes, हाँ. You were saying? समझ रहा? Spring वाला सवाल, हाँ. बोलो. Come again. but we are not concerned about that oscillation yet. Even if it oscillates, the net force acting in the system remains zero. ये मोशन होता रहेगा, ये मोशन होता रहेगा, दोनों मासेस एक्सेलरेट कर रहे हैं इंडिविजुअली, लेकिन जितना m में इसका है, जितना मास इनटू एक्सेलरेशन इसका है किसी भी पॉइंट ऑफ टाइम पे, उतना ही मास इनटू एक्सेलरेशन दूसरे का भी है इन द अपोजिट डायरेक्शन. टोटल नेट फोर्स इज जीरो. हाँ, सो मैंने वो मैसेज को हाईलाइट इसलिए किया बिकॉज़ दैट इज एक्चुअली राइट, प्रैक्टिकली राइट. आदिश, यस, हाँ समझ गया. बुलेट, अच्छा आईडी वाला, हाँ हाँ हाँ, बात करेंगे अभी आगे के 3 सेशंस में बात करेंगे उसको करेंगे, दोनों फिर अलग अलग एंगल्स पे करेंगे उस बारे में बात. अभी पढ़ा नहीं हमने, कोलिजन प्रैक्टिकली भी स्टार्ट नहीं हुआ है. दिस इज मोर ऑफ लोकल कंप्यूटर. हाँ चलो भैया, तो दैट इज ऑसम, दैट इज ऑसम. कीप इट अप, ओके. ओके, गुड नाइट, बाय. यस, बर्नाली, हाँ बताओ क्या डाउट है उसमें. एक्सप्लोर वाला क्वेश्चन किधर है यार, ये भी नहीं है, और ये है शायद से, ये भी नहीं है, ये है, हाँ यस. दोनों लिए, एक कोलिजन के पहले वाला केस, एक कोलिजन के बाद वाला केस, क्योंकि क्वेश्चन में हिटिंग हो रही है ना, इसलिए तो आइस मूव कब करेगी, जब उसको कोई हिट करेगा, तो हिटिंग के बाद वाला सिचुएशन. और हमेशा ये स्टैंडर्ड 3 सिचुएशन जो आज बताया मैंने, एक कोलिजन, दूसरा एक्सप्लोजन, और तीसरा कोई ऑब्जेक्ट चल रहा है उसके ऊपर कुछ और मास ऐड कर देना. ये 3 सिचुएशंस में लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम लगाने का है. कंडीशन फॉर मैक्सिमम, दैट्स कॉल्ड कंडीशन फॉर मैक्सिमम. वो पिछले सेशन में था. अच्छा, एग्जैक्टली क्या है, स्लाइड पे क्या हो रहा है, वो मैंने किसी को एक्सप्लेन किया होगा कुछ रैंडमली, इसीलिए आया होगा. वो मैं किसी को एक्सप्लेन कर रहा था, समबडी वाज आस्किंग सर मैक्सिमम नहीं समझ में आया किसी पार्टनरशिप पे वहां पर. बेसिकली कैलकुलस का पार्ट है डिफरेंशिएशन का. ये हमने पढ़ा था वर्क पावर एनर्जी में, जब हमने पोटेंशियल एनर्जी को इंट्रोड्यूस किया था, तो हमने वहां पे बात की थी इक्विलिब्रियम के बारे में. हमने बोला था कि कोई भी सिस्टम इक्विलिब्रियम में तब होता है, दो तरह के इक्विलिब्रियम हो सकते हैं, स्टेबल और अनस्टेबल. तो स्टेबल इक्विलिब्रियम जब होता है तो पोटेंशियल एनर्जी मिनिमम होनी चाहिए, और जब पोटेंशियल एनर्जी मिनिमम होती है हम डिफाइन करते हैं फोर्स एक्टिंग ऑन एन ऑब्जेक्ट और सिस्टम एज du/dr माइनस du/dr. तो अगर कोई भी सिस्टम में पोटेंशियल एनर्जी मिनिमम होगी तो उस पे लगने वाला नेट फोर्स शुड बी इक्वल टू 0. सो दिस इज कॉल्ड एज द फर्स्ट डिफरेंशिएशन ऑफ u व्हेन u इज अ फंक्शन ऑफ r. और इसी को जब डबल डिफरेंशिएट कर दोगे d2u/dr², अगर ये वैल्यू लेस देन 0 आई तो u इज मैक्सिमम, अगर यही वैल्यू d2u/dr² ग्रेटर देन 0 आई तो u इज मिनिमम. ये वहां एक्सप्लेन किया हुआ है मैंने बहुत डिटेल में, ठीक है. ओके, बाय, गुड नाइट. क्यों शिवम, मेरा पहला अप्रोच पसंद नहीं आया क्या? सर माय एग्जाम्स आर आल्सो फ्रॉम मिड सेप, विल यू डिस्कस ग्रेविटेशन बिफोर दैट? मिड सितंबर, आई डोंट नो, आई एम नॉट श्योर, देख के बताता हूं. रुको, मिड सितंबर से पहले ग्रेविटेशन आ रहा है क्या? यू कंस्ट्रक्ट, और ये ग्रेविटेशन खत्म हो जाएगा. ग्रेविटेशन विल स्टार्ट ऑन 22nd September, will end on 27th September. So after mid of September, gravitation will be done. You can definitely go for a micro course for that already. Sir, in maglev trains, what's maglev trains? There will be no friction. That is why they move so fast. तो those magnetic rails जो थोड़ा सा ऊपर चलते हैं ट्रैक से, वो वाली ट्रेन की बात कर रहे हो आदित्य? हाँ, magnetic levitation. Basically, if you try to reduce the friction, that you will be able to conserve more energy. That's it. Yes, Arshad. थोड़ा जोर से बोलोगे, मुझे कम सुनाई दिया. ये क्या, कौन से स्लाइड पे लिखा था? थैंक यू स्लाइड के बाद लिखा है, पहले लिखा हुआ है. लॉ ऑफ सुपर प्रिंसिपल ऑफ सुपरपोजिशन इज नथिंग बट लॉ ऑफ कंजर्वेशन, द पॉलीगन लॉ ऑफ वेक्टर एडिशन. तुम एग्जैक्ट बता सकते हो क्या हुआ है उस स्लाइड पे? जनरली प्रिंसिपल ऑफ सुपरपोजिशन में, जनरली प्रिंसिपल ऑफ सुपरपोजिशन जो है वो एक फैंसी नाम है जो हमने दिया है पॉलीगन लॉ ऑफ वेक्टर एडिशन को. जैसे कि एक बॉडी पे मान लो बहुत सारे फोर्सेस लग रहे हैं, F1 F2 F3 F4, ऐसे बहुत सारे फोर्सेस लग रहे हैं, तो इनका नेट फोर्स पता लगाते हैं बाय पॉलीगन लॉ ऑफ वेक्टर एडिशन. इसी चीज को हम प्रिंसिपल ऑफ सुपरपोजिशन बोलते हैं. Not the right platform to talk about it. Not the right platform to talk about it. I'm not the one who decides all these things. Arshad, end that point there only. When I'm saying I'm not the person who decides it, I'm not the person who will be able to help out. You have a SAM, student manager. Come again? बिल्कुल देखता हूँ, सारी देखी हुई है, पर उस पर मैं डिबेट नहीं करूंगा. मैं उस पर कोई डिबेट नहीं करूंगा, मैं उस पर कोई डिस्कशन नहीं करूंगा. क्या देखोगे? आई एम नॉट अपडेटेड येट. मैं भी अपडेटेड नहीं हूँ उन चीज़ों से एट द मोमेंट. ओके, ओके. गाइडेंस सेशन शायद से नहीं है, इसीलिए मैं हर बार क्लास के बाद में क्लास को एक्सटेंड करता हूँ. बिल्कुल, बहुत अच्छी बुक है, अच्छी बात. बिल्कुल, बहुत अच्छी बुक है. अच्छा, वेरी गुड. सॉल्व भी करना. ओके. You do realize there are many people who want to talk to me and ask their doubts, and what you are talking right now is actually Thank you. ओके आदिश सर मुझे म्यूट कर दो, मुझसे रुका नहीं जाएगा, तुम क्या बोल रहे हो? आई डोंट नो आदित्य राणा, आई एम नॉट अपडेटेड विद द लेटेस्ट टेक। और कोई सवाल जवाब डाउट या किसी का नॉन अकेडमिक डाउट था, मैंने उसे म्यूट कर दिया था, वो गाय। हाँ मुस्तफा, रुको भाई मुस्तफा, तुम्हें म्यूट करते हैं, अब नंबर आ गया तुम्हारा। यस मुस्तफा, यस आई लाइक योर नेम। आई ब्लॉक व्हाट? हाँ आई रिमेंबर, यस। I have forgotten the name of that guy, honestly speaking. Good that you cleared it up, though I have actually forgotten about that guy. I don't even remember that the guy also shares the same name. Someone with name? Jeff Bezos. I remember, I remember. Uh-huh. But have I said anything where I might have mentioned the name of that guy after you joined the class? This is basically your perception about that guy. Must have, your friend might have told you that something of this kind of incidents has happened, and maybe because of that, sir is giving you this vibe. Is that what? Right? I'm a very, very, very clear from heart person. If I have any, if I'm feeling irritated from somebody, I will say that on the face. You can get that very easily today. Once you got a scolding, once you got scolding here itself. That's, after saying it, I'm back to normal. I'm back to normal. I will not even be keeping any grudges on that basically. I wasn't even present in the class. Good that you cleared it up. Good, good, good. You brought it up and we cleared it. That's good. And I will remember that. And what's your full name, Mustafa? Mohammed Mustafa. Where are you from? You're from Kerala. That's good. I did not speak to that guy, I guess. I did not speak. He did not have a mic connected, and I wasn't even interested in talking to him because I kind of vaguely remember the incidents. He was writing something which is not appropriate. So I gave him the warning also not to write inappropriate stuff on the chat box, otherwise I'll block you, and I did that, and I completed it. That's it. In fact, that's what I think so. I haven't even spoken to because I usually remember people after speaking to them. I may not remember the names every time, but I remember the the voice, the generally everybody has a sound texture. That's what I remember. This guy actually has kind of, he might have had disobeyed all these because of, that's why. Very honestly, very honestly, Mustafa. See, the sanity of the class when it is an offline class is different, and the sanity of the class when it is online is different. People who usually will not speak ill stuff will start writing it on the chat box because they think that they will not be caught. This happens. So that's disadvantage you can say, but they don't realize that the other side of it is that they can be easily caught. In a class which is a physical class, if somebody in the backseat says something that some kind of mischief has been done, teacher may not be able to figure out who said something, right? But in online, it is absolutely pinpointed. It is pinpointedly figured out that who is the one who's creating the nuisance. It is actually in favor of the teacher. Yeah. I will anyway not ignore. I do not ignore students. You will not because I have long forgotten about that incident already. Okay, cool. Chalo then. Okay. Good night. Take care. Bye bye. Okay, Arshad. In fact, most of the schools are closed. Yeah. Vishesh says, sir, I have few fiction questions, but it requires diagram which I cannot tell you through voice. Can you please share your email ID? No, Vishesh. That is why there is something called as the doubt platform of Vedantu. You will have to post your doubts there. Okay. I have been given this instruction by the HOD himself. Okay. Or you can write a complaint email about me. अरे यार ये स्माइली होती है शिवम, मतलब क्या क्या सीखने आते हो तुम मुझसे, क्या होगा तुम्हारा मेरे बिना? ये जो है ये एक स्माइली है, इसको इसको 90 डिग्री से रोटेट करोगे तो ये ऐसा दिखता है, विच इज लाइक अ फेस वेयर आईज आर क्लोज्ड। ये वाला स्माइली है वो। ओके, फुल फॉर्म ऑफ ओपीए मैंने तुमसे सीखा है, ओवर पावर्ड होता है, मेरे को आज तक उसका मतलब नहीं समझ में आता। सर व्हेन इज योर बर्थडे? इट इज इन अक्टूबर। हाँ बट आई डोंट गेट द अंडरस्टैंडिंग ऑफ ओवर पावर्ड, व्हाट डज इट मीन? ओवर पावर्ड का मतलब क्या है? मतलब somebody has actually taken over। I know it is something related to PUBG, but I have never played. I've never seen that game, so that's why I don't know. Sir, मुझे भी आज पता चला। Okay, sir, I'm a ProLite user. How should I ask the doubts? You'll have to speak to your Sam for that. विशेष Sam से पूछना पड़ेगा बच्चा। Okay. And Vishesh, by the way, there are Tattva discussion sessions. Okay. Please tell how to face burnouts. What do we mean by burnouts? Vishesh, please write an email about your situation at vcare@vedantu.com. vcare@vedantu.com. Just write your situation. They will get back to you with the solution, Vishesh. Okay. That's what I'm saying, Vishesh. I'm giving you my humble suggestion here. Shivam, to you as well. Write your concerns on this email. Okay. सर आपके चश्मे का क्या नंबर है? 0. It's a UV protection lens. 0 नंबर है. मेरी आंखें बिल्कुल ठीक है. Yes, Jay, tell me. In situations, it will depend upon how you are choosing the system. What system choice you have. In a whole. Exactly, that is why. In a larger scheme of world, in the universe, definitely momentum will always be conserved. Because every time you will definitely have a reaction force. But what is your choice of system will enable you to apply or not apply law of conservation of momentum. What? I'm not able to understand. What are you trying to say? That question you're talking about. M1 x1 minus m2 x2 upon m1 minus m2. Yeah, because when we write a mass like this, okay, if I talk about sigma is the mass density. If I take sigma value as 1, then mass is proportional to area, right? That's why. We can, yes, we can. Okay. But this is the proper understanding of it. Okay. Which chapter? Which chapter? Tattva. But Tattva discussion sessions are separate. Jay. There are 4 masses, they are placed on the 4 corners of the square. And so how can you get 2 different answers? This is where the center of mass will be. Yes. What the question is asking you is the value of m, right? So where is m1 placed? This is m1. How much is it? 2m. It is 2m. What is this corner? This is 4m. This one? And this one is m4. So this is not given, right? Let's consider this as, say, let's consider it as m dash. What is the side length? Given or not given? Not given, no? So we will consider the side length 2a. We consider it 2a. So coordinate of center of mass becomes a comma a, right? So x coordinate of center of mass is a. First mass is 2m. Okay, first mass is 2m. Okay, so yeah, how much? That's okay, no problem. The answer will not be dependent on that because we are looking for the mass value. We are looking for the mass value. Okay, so it will not be dependent upon the side length. So if this is 2m, the coordinate is 0, x coordinate is 0. 4m, the x coordinate is 2a. Okay, then you have m, whose x coordinate is 2a, and this mass is m dash, x coordinate is 0. Getting? Divided by the total mass, which is 7m plus m dash. This becomes 0. 7m plus m dash goes to the left hand side, multiplies with a. This is 0. 8ma plus 2ma is 10ma. A and a gets cancelled. M dash comes out to be 3m. That's the answer. That's the answer that you will get. You can try one more time. That is the answer that you will get for sure. Okay? Try one more time. Nihal, 1D objects के लिए lambda, 2D objects के लिए sigma, 3D objects के लिए rho. 1D object sigma, 1D object lambda, 2D object sigma. Sir, will we have one-shot revision sessions on the chapter we have completed here? Hannah, do you mean on YouTube? Do you mean on YouTube? On this platform, no. There are micro courses for that. Okay. Sir, 6 hours sleep well enough क्योंकि self study को time कम हो जाता है. 6 hours is actually not bad. It's a good amount of time. Burnout is a form of exhaustion caused by constant feeling swamped. It's a result of excessive and prolonged emotional, physical, and mental stress. In many cases, burnout is related to one's job. Burnout happens when Mr. Adish. Burnout only happens when your self motivation is not there. When you yourself are not sure why you want to do what you're doing. If you are 100% sure what exactly you're doing and why you're doing, why are you preparing for JEE, you will never have the feeling of burnout. You will only feel a little tired, but the inner fire will always keep you going. So that's why I always say, always ask yourself why you're doing what you're doing. Nobody's forcing you to prepare for JEE. At least the government of India is not. Unlike your board examinations, which is a compulsion. You can't give up only when you are strongly aware of the fact that why are you preparing for JEE. Ask yourself. If that reason is strong, whenever you get the feeling of burnout, think of that reason. It will give you that fuel. It will give you that motivation. Okay. Okay, everyone. Should we call it a day? Let's wrap it up. We'll meet again on Wednesday. We'll continue from here. Okay, everyone. Bye-bye. Good night. Hasta la vista. Sayonara. See you all on Wednesday. Love you. 300 only, not 3,000. Should be 3,000, huh? Yes. Sure then. Yes. Bye-bye. Good night. Signing off now. Banali, that's Iron Man, Avengers, last part, whatever that was. Okay, Endgame, Infinity War. Yes. Sure.